Look at this equation. X equals 2, parentheses, 7 plus 5. A human instantly recognizes the implied multiplication here. We know the 2 should be multiplied by the sum inside the parentheses. Computers are incredibly fast, but they possess zero intuition. They cannot guess your intentions. They only follow the specific symbols you provide. This rigidity is absolute. If you type the number -100,000 with a comma, the machine doesn't see a large number. It sees a syntax error and stops. Even a simple sentence can cause a crash. Trying to add the number 50 to the text "is a number" triggers a logic panic because the computer cannot merge two different categories of information on its own. To control the machine, we have to abandon human assumptions. We must categorize every piece of data and provide hyper-explicit instructions for every interaction. Python manages information through a strict internal filing system called data types. These are the nouns of the language, and every value must be sorted into a specific category. Whole numbers are filed as integers, or ints. To be accepted, they must be written cleanly, without commas or non-numeric characters. Numbers with decimals are filed as floating point numbers, or floats. This distinction is so precise that Python even treats -0.0 as a valid, distinct floating point representation. Text belongs to the string category, and simple logic states, like true and false, are filed as booleans. You can verify how Python sees your data using the type function. It allows you to peek into the filing system and see exactly how a value has been categorized. Organizing these nouns is only the foundation. The machine's utility increases as we move from simple storage to active manipulation. Manipulation happens through operators. These are the explicit tools, the verbs that force data types to interact. Standard math operators perform addition, subtraction, and multiplication. If both values are integers, the resulting answer is an integer. Division follows a different rule. Using the division slash automatically converts the result into a float, even if the division is perfectly even. Python also includes specialized logic tools. Floor division divides numbers and discards the decimal, while the modulus operator ignores the whole number to return only the remainder. For raising a number to a power, we use the exponentiation operator, written as 2 asterisks. Applying these tools resolves our earlier error. By including the explicit multiplication asterisk, the machine no longer has to guess. It simply executes. Comparison operators allow the machine to evaluate data, acting as gates for the program's logic. The equality operator uses 2 equal signs to check if values match. The inequality operator, an exclamation point and an equal sign, checks if they differ. Logical operators chain these evaluations together. The AND operator requires every condition to be true for the code to proceed. The OR operator is satisfied if even a single condition is true. By combining specific data types with correct operators, you dictate the exact flow of the program. We can now resolve the crash from Act 1. The integer 50 failed to combine with a string because the computer lacks the intuition to translate them. We fix this using type conversion functions. These act as translators, forcing one data type to take on the characteristics of another. By wrapping the number 50 in the str function, we convert it into text. It can now safely merge with the rest of the sentence. Mastery of these rules clarifies the logic of code. Every line dictates a specific interaction, operating with the mechanical precision of a high-end timepiece. Writing code is not a matter of magic or mystery. It is the practice of being rigidly clear in your intentions. By mastering these nouns and verbs, you align your instructions with the machine's architecture, leveraging its speed to execute complex tasks with absolute reliability.